Okay, in this video, we're going to derive a formula that will tell us what the angle is between two intersecting curves, providing that we know what the slope of those curves are at the point of intersection. And here we have this curve here we labeled as C1, and here we have this curve that we labeled as C2. And at the point of intersection for curve C1, we drew this tangent line here, L1, so the slope of this line is equal to the slope of the curve at that point of intersection. And likewise, we've done the same thing with L2. That's equal to the slope of this curve here at the intersecting point. And tangent line L1, we say that that makes an angle of θ1 with respect to the x-axis, and L2, that makes an angle of θ2. Okay, and what we're interested in is this angle between the two curves, or between these two tangent lines here, L1 and L2. But first, let's talk about the slopes of L1 and L2. The slope of tangent line L1, that's equal to delta y divided by delta x. And here, let's just, before we take this formula further, let's just drop a vertical line here, like this. So we have this triangle right here. And we want to know about the slope of this tangent line L1. So that equals delta y divided by delta x. And we can just say, in general, it has a y value here. We don't have to specify what it is. But delta y then, going from here to here, that equals y minus 0. And let's say this is x2 and this is x1. So delta x is x2 minus x1 as we consider this region here. So that's x2 minus x1. And if we look at it again, y, of course, that's just the value of this vertical line that we constructed. x2 minus x1, that's just the length of this side of this triangle. So we can say that the slope of this line here is equal to the tangent of θ1, theta being the angle that it makes when it intersects the x-axis. Now what about M2? Well, we can drop another vertical line down here, all the way down if we want to, and then we'll be dealing with this triangle here, with this angle. This is the reference angle for θ2. θ2 is greater than 90 degrees, so we take sines or cosines or tangents, we do it with regard to the reference angle. Also notice, of course, that L2, that has a negative slope. So the slope of this tangent line L2, it equals minus the tangent of this reference angle. And what is this angle? It is pi minus θ2. Now let's look at this expression for a moment, though, because the tangent, you know, we have this formula, the tangent of A minus B, that is equal to the tangent of A minus the tangent of b divided by 1 plus the tangent of a times the tangent of b. Here we have pi minus theta, so that's going to equal pi minus theta 2 actually. And using this formula, this will equal the tangent of pi minus the tangent of theta 2 divided by 1 plus the tangent of pi times the tangent of theta 2. For the tangent of pi, that's the sine of pi divided by the cosine of pi, and the sine of pi is 0, so this is 0, this is 0, so this here just equals minus the tangent of theta 2. We've got our minus sign here. So going back to here now, m2, that equals minus the tangent of the reference angle, and the tangent of that reference angle is minus the tangent of our theta 2, so it's m2 is equal to the negative of this negative. In other words, m2 just equals the tangent of theta 2. So in each instance for our tangent line segments, their slope is equal to the tangent of the angle that they make with respect to the x-axis. Now what we're interested in, though, is the angle between the two curves, or between these two tangent line segments, and we'll call this angle, let's call it beta. And that means, so that this angle right here, that's also beta. So we have this triangle here, here, here. This is angle theta 1. This is angle beta, the angle between the curves, and that's pi minus theta 2. So we have theta 1 plus beta. This angle plus this angle plus the smaller one has to add up to 180 degrees, or the pi radians. So phi 1 plus beta plus, this is pi minus theta 2. Those had to add up to pi. We can subtract pi from both sides of the equation. And we have minus theta 2. We can bring that over to this side. Here we have plus theta 1. We can bring that over to this side. And we have that the intersecting angle is equal to this angle minus this angle. And that's good as far as it goes, but there's one more step that we can take with this. The tangent of this intersecting angle that will equal the tangent then of theta 2 minus theta 1. And using our formula from up here, that will equal the tangent of theta 2 minus the tangent of theta 1 divided by 1 plus the tangent of theta 1 times the tangent of theta 2. But we know that this is equal to the slope m2, and this is equal to the slope m1. So let's just rewrite this. The tangent of the intersecting angle between the curves is equal to m2 minus m1 divided by 1 plus m1 times m2. Now, we were talking about M1 and M2 as being equal to the slope of these two different line segments here. That's true, but it's also equal to the instantaneous slope of these two curves here. M1 is equal to the instantaneous slope of curve C1 at the intersecting point, and same thing for M2. Well, we can easily enough find out what they are, M1 and M2, simply by knowing the equation for the curves and then taking the derivative of it. So we can easily enough at the point of intersection determine what M1 and M2 are, which means we can very easily get what the tangent of the intersecting angle equals. Also, this tells us something else. Suppose we have two curves or two line segments and they are perpendicular to each other. So now we're going to be taking the tangent of pi over 2. And that equals the sine of pi over 2 divided by the cosine of pi over 2. But the cosine of pi over 2 is 0. So this is undefined when the two curves are perpendicular. But this is also equal to this, and this expression here will be undefined if this denominator is 0. So it means then that when the curves or the line segments are perpendicular to each other, M1 times M2 has to equal -1, so that this becomes 0, and this whole thing becomes undefined, just as the tangent of pi over 2 is undefined. And that means then that M1 equals -1 over M2. So this is why when you have two intersecting curves or two intersecting line segments, if they're perpendicular to each other, then their slopes have to be negative reciprocals of each other. So that's what I want to point out from this video. Again, if you have two intersecting curves, and assume that you know the equation of those curves, so you can take their derivatives, and you know the point of intersection, then you know what M1 and M2 are, the instantaneous slopes at that point, and you can very quickly find out, or at least get an expression for the tangent of the intersecting angle. And also the same formula explains to us if you have two perpendicular line segments or two perpendicular curves, those slopes have to be negative reciprocals of each other. Okay, that's it for this video. Come back and join us for some more videos, and we'll try to get back to working some more problems.